So I'm going to talk also about VR. There's two parts to my presentation. So I'm a neuroscientist by training, and we're trying to link virtual reality and neuroscience for two things. One's using virtual reality to learn more how the brain works, and then also having understood something about this relationship, maybe also some of these findings can help to improve also VR-based AR, ER technologies. And then the last part is that we're very interested in also applying this, and this is the main part of my talk, to like the talks before, to clinical conditions. And we call this, or we refer to this as immersive digiceuticals. I think I'll skip this, or basically just tell you that, as I said, so there's neuroscience and engineering that we're involved in, and this is our basic research working on consciousness, cognition, and human augmentation. We try to bring this to these medical fields, and then there's also, since there were startups mentioned before, so there's 3 startups that I have been involved with. MindMaze, I think, has given some talks before as a former student of the lab, and there's Inverse. I think later on there will be a demo as well, and most recently we have also started together with Simone Gallo, who is also here, linking VR to haptics, and it's a very recent startup. But what I talk about mostly today is this part here in the middle. It's how can we use VR, immersive VR's immersion embodiment, in order to provide novel treatments for patients who have, in particular, pain, chronic pain. And this links also the fields of neuroprosthetics. And then in the end, if we have time, there's also related work about human augmentation, not just treating and repairing, if you want, painful body representations and perceptions, but how can we generate scenarios where people experience and can actuate multiple arms, multiple fingers, or surrogate bodies. And in order to start, there it is. So normally that's how neuroscientists look at the body representation. Whether you are a mouse, a monkey, or a human, you have a very similar representation in the brain. And you can see, for example, here, red parts are the very typical location up there. The face, blue, is lower down here, and so on. There's really a map, a geographical, topographical map how the body is represented in the brain. And as I show you here, this is really all species that have the same representation. Now, how we look, or much more interesting representation in the brain, the first representation is here. Other representations more in this posterior part of the green area, they do different things. It's not just about touch, but they're also like, should you look at your hand, they integrate this information. So these are brain signals that are not just there about feeling hand representations, but it's the same representation whenever you feel, hear, or move your hand. So there are certain brain areas that prefer signals which is a more true signal of how the body should be represented in the brain. It's touch, it's movement, it's sound, and of course you can snap your finger, and that also activates these same cells. And this is an illusion that you have probably heard about in previous presentations. It's the rubber hand illusion. So there's a hidden hand here. The tactile cue is applied here. So you feel the touch here. And then there is the second hand, or the rubber hand if you want, which is threatened here. And so what this illusion does, it creates a link between the hidden hand and the felt hand. And of course, normally under normal condition, this is always felt at the same position. But what this experiment does, very simple, is to dissociate the two, okay? It looked a bit ridiculous on this, particularly since the video didn't even play right, which I don't know why that's the case, but in any case, you do this for a minute, and in the large majority of us in the room, we would induce the rubber hand illusion. 2 things: you feel that the pink glove feels like your own hand, and if you're asked to locate that hand, if you're asked to point towards towards your hand, you don't point towards your real hand position, which you're supposed to do. You sort of shift it over to the fake hand's position. So basically, you make lots of errors very easily in experience, because you should not make errors where your hand is in space, and your brain automatically miscalculates this. So believe it or not, so there's about 100 studies today on this rubber hand illusion. We know very much where these brain areas are that are involved in this. And however, the aspect that we're looking at in the lab is more related to a global aspect. So we're not just looking at how is my body representing my right hand. Let's say, how is my entire global body represented? And for this, together with several people in the lab, we've used these different video initially, but also virtual reality animations, where based on a camera where the body of the subject is filmed. This is projected in a front space. There's a video here, so a subject is fitted with a head-mounted display. Some of this research dates to about 15 years back, and then a tactile cue is applied, just like in the rubber hand illusion that you saw before, but the subject obviously feels it at the back, but as you can see here on the head-mounted display, you see the touch 2 meters in front. So just like in the rubber hand illusion where there was the mismatch to see the hand at a different position than where you felt it, here you feel the touch at a different position than where you see it. Namely, you feel it on your back, but you see it 2 meters in front. And so here's the setup again. So this is the experimental subject. The camera is standing here behind. You have, this is the virtual body, the avatar that the subject is seeing. And then very much like in the previous rubber hand illusion, we apply a touch cue here, which is felt here. So you have this mismatch, and we're exposing this brain to this conflict. Because right now, if I were or somebody were to touch my body, obviously I would look down, I would see the cue right where it should be. But the brain is not used to it, and strikingly enough, just like in the rubber hand illusion before, we can induce two states. First of all, there's identification of our subjects with the avatar that they see. So this is an automatic mechanism of embodiment or presence at the level of the avatar if you want, and this can be measured as in these conditions here. It's very easy to design a control condition, because if you see the touch at a different moment that you feel it on your body, this illusion breaks down. This is shown here in the dashed condition. And then here, this is also mislocation of touch. So people not only identify with the avatar, touch is also felt at the visual position and not here where it physically is applied. And then we can also, we designed several measurements how to measure not just questionnaire response, but also ask people for, like in the previous presentation, for an implicit response, right? We ask them to indicate to us the position where they have been standing during the illusion, and they make systematic errors, again, shifted in the direction towards the avatar. Much of our work actually in the past years was, how can we bring VR to this environment here, which is the main technology used in human neuroscience, mapping the brain regions, but I didn't want to talk about this here today, but we're very interested in what happens in the brain of people exposed to VR. What are the changes, and are there any systematic changes? What I want to focus now on, and the rest of the talk, is digital, immersive digiceuticals, and this is basically one of the applications, of course, that VR and this embodiment of VR, controlling how we perceive our body in VR, can be used. The first condition, extending from more psychological and mental disorders that we've heard about before to physical mental disorders, namely chronic pain. You see two examples here. So this left arm here is complex regional pain syndrome. So there is, let's say, something very frequent actually happening here in Grand Montana, which is you have a snowboard accident and there is a fracture. It's a minor accident initially, but after 3 months, the patient continues to feel pain. You can see another example here, and several treatments have been proposed. I think Hunter Hoffman was here 2 years ago, so this is part of the work that inspired our work. But however, the way VR was used there is more like a distractive cue. But what we wanted to do is build something like the rubber hand illusion I showed you initially, and really use VR to automatize this kind of therapy. And of course, very obviously, if you take, there's a lot of strong pharmacological therapies, but they all have side effects. And moreover, particularly for chronic pain, they do not work very well. And if you take examples from the US with the opioid crisis at the moment, acute pain, these therapies are very prominent and very efficient, but they have really major side effects. So what we developed, also together with Bruno Herbelin here in the audience and in the lab, is a cardio-enhanced embodied reality therapy. And this is what this is what the scenario looks like. This was Marco, not a patient, but what we did, instead of applying a touch cue towards the hand of the people in pain, because very often that enhances pain rather decreases it, we used, based on a lot of other research in the lab, the cardiac beats, the heartbeats of each patient. As you can see it here, it leads to a flashing of the hand, and then we illuminate your hand in synchrony with online detected heartbeats from each patient. And when we do this, so this is a new form, a new version of the rubber hand illusion, now not based on linking vision and touch, but linking vision and the heartbeat. You have three main effects in this first study, again, that were important to quantify. First of all, you can see in our experimental condition, the values are negative, so there's a decrease in pain, so this is subjective. You give patients a pain rating, and then these pain ratings decrease. Something very surprising for me at the time, normally when you have chronic pain, the strength of the upper limb decreases for the painful hand. And what we could see here, if afterwards we test the strength of the people recovers. And finally, there's a more automatic pain marker, which is also normalized. And we're continuing this project actually at the moment together with MindMaze in order to bring this not to the 40 patients we've tested so far, but ideally we'd like to test about 400 patients, and this will be a study in the US. So here so what are other conditions where we can apply this technology? So here is another scenario where you can now take this automatic link between vision and touch and vision and cardio, vision provided through VR. And we had the opportunity to test another patient who had an artificial limb. This is an amputee patient. This is work done by Giulio Ronini. And so you can see there, what is shown here in blue in this video is there is no arm at this position, but now we have the possibility, because the patient perceives a phantom limb, like in this blue position. And we have also, as this video will show you, an electrode going directly to the nerve. So we can stimulate that nerve, and that leads to a fingertip sensation in the phantom limb, in a physically not even existing hand. And what VR will give us as an opportunity is to illuminate by VR the virtual hand, overlaying it over the position of the phantom limb, and then see whether we can induce not only ownership illusions like I showed you before, but also basically give people in the future prosthetic device a feeling as if it were a real hand of flesh and bone, etc. So the video is here. So you see there are small electrical currents going into the nerve, leading to the phantom finger sensation at this position. We fitted the subject with a virtual reality headset, and then could illuminate the prosthetic device exactly at the position where the patient felt the touch. So now you basically induce a rubber hand illusion even for a hand that physically doesn't exist, showing you again the power of embodiment in VR, and I think of VR generally. I won't go into much detail about the data, but again, we could induce the standard rubber hand illusion even in individuals who don't have a hand, but remember they have their brain representation of the hand, and VR will mostly work or access this brain representation of the hand, and mostly so. People have a miscalibration, and very important for us in this project and for the main author was that we could have beneficial effect for pain. So pain decreases when, and Dennis in this case, the patient was exposed to this kind of therapy, and in total we tested 3 individuals. This is the third applications, again, immersive Digiceuticals, sort of version 3. Now we did not link peripheral nerve stimulation in an amputee patient, but we linked virtual reality with another kind of brain stimulation now, the spinal cord, so chronic severe pain. One of the very prominent therapies, if pharmacology does not work, is to use a stimulator over the spinal cord. The spinal cord will induce paresthesias, so tingling over the painful body parts. But it has never been linked with VR before. But we have a very straightforward a solution to propose. We're not only going to induce tingling in a certain body part based on the stimulation here, but we're going to use VR and the same kind of technology that, again, has been initially developed by Bruno Herbelin and then tested by Marco Solca. We overlay exactly where the patient feels the touch, the paresthesia. We overlay a visual cue and we immerse the patient in addition, either in this sad, well, nice hospital somewhere in the US, but of course we can also have then a lot of freedom to put him on a beach or to put him at any other location. Unfortunately, that manipulation did not lead to any changes. So somehow patients seem to still prefer to be in a hospital sometimes than on a beach if they at least receive therapy. And I'll be brief on this. Our experimental condition is the red one, and again a decrease. So each time we apply 6 or 7 times in a row, there is a successive cumulative decrease of the pain threshold. The nice thing in this study is if you wait for an hour and test pain thresholds again, the pain effect persists. So it's not just over once the VR is over. So VR, especially, this is another project we're going to continue in the US with a VR company. The idea is to test larger groups and see whether if you're exposed 3 times per day for 4 weeks, whether this can have effects over longer periods of time. How am I doing with time? I'm running a bit through this. 10 more minutes? 7 minutes, okay, great. So in general, just in my field, in the field of neuroprosthetics, people talk a lot about pharmacological therapies. Obviously, this was a revolution. Unfortunately, in the field of mental health, 60 years ago, believe it or not, I think not much has actually happened since then. Specifically, the neurosciences, the outcome of pharmacological new drugs is almost zero these days. Electroceuticals is something new that comes, and I gave you 2 examples of spinal cord stimulation and peripheral nerve stimulation, but what I think is going to be really powerful and impactful, reaching a lot of more patients than any of these new therapies here, will be the digiceutical revolution, particularly immersive ones, and particularly body disorders, but we've seen other examples in the presentations just before. And I want to conclude just with other examples how we use VR in the lab, maybe more medically linked and particularly related to human augmentation. I mentioned it briefly. There's a lot of work coming from robotics, and I think VR will have a large contribution as well about supernumerary arms. There's many applications. This is an example from MIT, where of course, I'm sure many of you in the room would have wished to have an extra arm when you're doing some of these tasks at home. What we have been involved in again is prosthetic limbs and artificial limbs, like you can see another patient we've worked with. But one example I just want to highlight here is something that we've worked on is supernumerary fingers. And some individuals are born, I mean, you have to look carefully here, it's not 5 fingers, it's 6 fingers, and we've looked. If you're born with 6 fingers on the right hand, total of 12 fingers, total of 12 toes, the brain does not really care. If you have 6 fingers, you will find 6 finger representations in your brain. And so as you can see here, there is a second index finger sort of between thumb and the real index finger. And in the brain, it was exactly at the predictable location. So I just highlight this here to show if there is a 6th finger, if there is a second right arm, the brain will incorporate this. And VR could, of course, be the first and the most frequent tool to expose us to surrogate arms, surrogate fingers, and alternative bodily realities. So some of these other bodily realities and sensations we've been interested in is, I think there's a demonstration of the Birdly device flight simulator also here. So we have again looked at what's the component of embodiment for inducing and enhancing aviation experiences. So this is one of the studies that we do in collaboration with an aviation robotics lab at EPFL. So you see the standard device here. And Myong, he has built a haptic vest in addition to automatize this avatar illusion that I mentioned to you. And what we're able to find is that we can not only induce very strong sensations of flying, as well as embodiment for this avatar that you can see here. What is interesting here is targeting performance or pilot performing, so to really have gaming performance improved in order to meet that cloud. Manipulating embodiment, like I've shown you before, is a very powerful means to do so. And again, the advantage then is there's a whole amalgam of neuroscience finding behind it, so you can also speculate very precisely about what the brain mechanism is involved. And that's the last project I wanted to present. So we link another form of flight experience, namely we've built this automatized drone setup where when you're walking in space, like you can see this subject here, there's an automatized drone following you, shifting the position of your eyes from the position where your eyes obviously really are to the drone following you 2 meters behind. And so we were very interested in investigating here whether we can shift selfhood or ownership from the position where the subject really is to the position of the drone. And we actually find evidence that the brain shifts resources and distributes them between these two positions. So again, if you have 6 fingers, the brain will adapt. If you have 2 stable body representations of me in space here and being in the audience at the same time, the brain can be made to not only feel these as basic body representations, but actually does represent them as 2 separate selves in the brain. And yeah, it's a bit brief and an overview I wanted to give you. So one take-home message is that VR, AR, MR, XR, I think embodiment, ER, embodied reality, is a very powerful tool to impact on all of these. There will be no VR without some basic body representation, and VR is not only a fascinating tool to manipulate it, but this knowledge can also be used to create entirely novel scenarios. Embodied reality is powerful as a digiceutical tool, and finally could also be powerful for human augmentation. Thanks.